Hey young men, Mr. Maldonado here. Alright, so in this video, we're going to be looking at 4 different questions that are going to help you for your 6 weeks test next week. We're going to look at 1 question on density, 1 on elements and compounds, 1 on chemical changes, and finally 1 on metals, nonmetals, and metalloids. So as a good review, you should probably try to answer the question first on your own, and then watch the explanation that I'm going to give to see if you did it correctly. Alright, so let's get started here with number 1. Number 1. John uses a balance and a graduated cylinder to determine the density of an unknown substance. The unknown substance has a mass of 2 grams and a volume of 4 cubic centimeters. What is the density of the unknown substance? Bubble in your answer in the griddable. Will the unknown substance float or sink in water? Hint. Water's density is 1 gram per milliliter. Alright, so let's try to remember. What is the first thing you should always do? The first step in working with the density problem. Always make sure you write down exactly everything that you know. D equals, M equals, and V equals. Alright, do we know our density yet? Nope, that's what the question's asking here. What is the density? So we put our question mark. Do we have our mass yet? You betcha, right here. Mass of 2 grams. Do we have our volume already? Right again, it's right here. Volume of 4 cubic centimeters. What's step 2? Exactly. Let's write our formula triangle the way it's supposed to look. Density down there, mass on top, volume. Don't forget your multiplication symbol, division, and IO for inside the house and outside the house. Alright, so let's rewrite this triangle with the actual numbers though. Alright, what do we put for density? Exactly, question mark. If you don't remember, look back up here. What about for volume? Great job, we use 4 centimeters cubed. Finally, what do we put for mass, which goes in the top part of the triangle? Exactly. 2 grams, right here. Am I done with my triangle? Of course we're not. Make sure you put multiplication, division, I, and O. Alright, so now let's work on our actual division here. We know we're going to divide because the line that separates 2 grams and 4 cubic centimeters is this line right here, and that leads us straight to division. So now remember, the bigger number doesn't always have to go inside the house. Whatever number is on top goes inside the house. That's where our I comes into play. So we have 2 divided by 4. So let's work on this. Can 4 go into 2? Nope. 0. What's 4 times 0? Great job, 0. 2 minus 0 is? Excellent. 2. Add a decimal, bring down another 0. 4 into 20, how many times? Great job, 5. What's 4 times 5? Awesome, it's also 20. So 20 minus 20 is 0, and we're done. So our density equals 0.5 grams per cubic centimeters. So make sure we bubble that in correctly, 0.5. Great job, guys. Alright, so let's move on to question 2. Number 2. A compound is formed when 2 or more substance different elements are chemically combined. Which of the following model descriptions best describes a compound? Alright, so some keywords here would be compound, formed when 2 or more different elements are chemically combined. So which of the following model descriptions best describes a compound? So let's review the difference between an element and a compound. Remember, an element equals one thing. It's made of one thing, just one pure substance. A compound, however, is made of 2 or more different elements. And that's exactly what we have written here in our question. So we did something similar to this week in our revolution stations with our Legos, alright? And if you're not sure, if you don't remember exactly what we did with those Legos to model elements and compounds, there are several videos here on this YouTube channel of certain students in class in different classes that are modeling those elements and compounds and explaining how their models are elements or are compounds. So let's look at letter A. Jane linked different colored bracelets together. When you link something, okay, and so write this down in case you're not sure what the word means. When you link something, you're connecting them, all right? You're combining them somehow. So if we connect different colored bracelets together, could that possibly be a compound? Yeah, it can. Let's go to B. Joe uses different, so again, we have the word different here, colored pencils during the day. All right, so he has different colored pencils. You know, that could represent the different elements, but are we chemically combining them, like it says in our question about compounds? No, he's not connecting them or combining them in any way. He's just using them throughout the day. So B is definitely not our answer. Letter C. Helen wore two different, again, we have the word different, colored socks. Alright, so once again, her different socks could represent different elements. But is she connecting them or combining them in any way? No, she isn't. So because there's no actual combination of these differences, letter C is not our answer. That is not a description of a compound. Letter D. Jake wore all red one day. So if he's wearing all red, there's nothing different there. It's all red. It's all the same thing. So that would actually probably represent one element right there. That's what that would represent. So that's not our answer because it's asking for the best description of a compound. So what's our only answer? Great job. Letter A would be our answer for the best description of a compound. Alright, let's go ahead and look at question number 3. Julie made the following observations during an experiment. Bubbles were formed, the temperature after mixing the two chemicals increased, and a precipitate or a solid was formed. Which of the following is the best evidence of a chemical change? Alright, so when we talk about chemical changes, we said that there's two things that we're always going to write down. We talked about this. Always write down new substance, and also you write down cold pig. Alright, so let's look at new substance and cold pig. What is the one thing from here that we said that all chemical changes always have in common? Great job. The one thing they have in common is that they are all forming new substances. When we look at cold pig, those are different types of evidence of a chemical change taking place, but like the C says, change in color. Not all chemical changes will produce a change in the color of the substance. Not all will produce an odor. Not all will produce a light. Not all will change the temperature. Not all will form a precipitate. All of them will be irreversible because there's a new substance, but not all will produce a gas. So that's why new substance is the one that covers all chemical changes. So let's look at the best evidence. Letter A says bubbles were produced. Where do we find bubbles in a cold pig? Great job. That's in the G for gas. What about the temperature increased? Where do we find that in cold pig? Exactly, great. It's found in the T for temperature change. What about a precipitate was formed? Where do we find that? Exactly, it's in the P of cold pig for precipitate. And finally, we have a new substance was formed. Alright, so technically all four of these could be possible evidence of a chemical change. But again, which one is the best one? And we're talking about a chemical change in general, not a specific one. So which one covers all chemical changes? Exactly. Letter D. And that's exactly why letter D, a new substance was formed, is the best evidence of a chemical change. Alright, let's go on to the last question, number 4. Question 4. Which of the following, sorry about the typo, is a physical property of nonmetals? Alright, so we have our keyword nonmetals. There's something I told you to write down. Whenever you hear see the words nonmetals, metals, metalloids, shiny, brittle, anything like that, always write down these two strategies that we use. We use Magouladou, and we use that for metals, and we have BID, and we use that for nonmetals. Remember, metalloids use both Magouladou and BID. Alright, so the question again wants to know, which of the following is a physical property of nonmetals? So, should we use Magouladou or should we use BID? Great job. We're going to be using BID because that's talking about nonmetals. So what does the B stand for? Exactly. Brittle. What does the I stand for? Great job. Stands for insulator. Finally, what does the D stand for? Great job. Dull. Okay? So when looking at our answer choices, we need to find the one that matches either brittle, insulator, or dull. So which one do you see? Great job. Letter A, brittle, would be the answer. Now letter B, a lot of luster, that is found in the LU of Maguludu. Letter C, great conductor, is found in the GOO for good conductor. And letter D, turns into wire, is found in the DU of Maguludu for ductile. So that's why our only answer would be letter A, brittle. Alright guys, so please make sure that you comment that you put a comment either with a question about the video or something you learned with the video or some interesting fact having to do with anything at all that we've been learning in class that will be on your 6 weeks test. Alright guys, I'll see you all on Monday.